So this problem is another very good example to look into the sliding window technique. The longest substrings without repeating characters. As you can see, longest substring, right? So we do see those patterns which sliding window, which we have seen in the sliding window techniques introductions. So this is how you identify. So if you read the question itself, right? Given a string as, find the length of the longest substrings without repeating characters. Longest substring, substring, subarray, longest, right? So these are the keywords you should look out into the questions that will indicate that it is a good candidate to apply the sliding window technique. So let's see in this examples, right? If you will get an string as ABC, ABC, BB, the output should be 3. And as per the explanation, the answer is ABC with the length of 3. Similarly, if the string is all BBB, the output should be 1 because B is the only character which is a unique and it's not repeating. Similarly, in the third example, PWWKEW. So if you see PWW, first this WKE is the unique substrings without repeating, right? So let's see how uh, we can approach to this problem. So here is the example, the third example from the questions. The string as is PWWKEW, right? And since we are using the sliding windows, we for sliding window we know that we need two pointers, right? So the first pointers is left pointer, which will be uh, which we are going to use for contracting the window, okay? And the right window, right pointers for expanding the window, okay? So both initially both the pointers, what happens is both these left and right pointers are pointing to the first character, right? And that's the first characters. We use the right pointers to extend the window. So the next the right pointer is pointing to this, left pointer is still pointing to the P, and now we have the two elements that's are the unique, it's not repeating. We can keep extending the window. The right pointer is now pointing to the W. Now W is already present. That means we have to contract the window. So in that case, we're gonna move the left pointer to point to the next element, and we're gonna keep doing that until there is no, yeah, duplicates elements in there. So ultimately we reach to this levels, that's the W. So again the left and the right pointers are now pointing to the same elements. We are again expanding the windows using the right pointers. Now the W, K, and then E, right? So at E is still unique elements. So W, then K, then E, it's all unique. And as soon as the right pointers point to the W again, we already have these elements right here. So that means we have to contract the window. And as we know that while we are doing the contractions and the extension of the window, we have to keep track of the length. What is the length of the substring? So this is where the length is 3, the first two is the 2, and then here again this is 3 and this one will be 2, right? And out of this we have to return the longest one, which is 3, right? So let's see, here we have three things, right? For writing the algorithms, we need to have left pointer and right pointer. Then we also need some mechanism that will keep track of the uniqueness of the elements in that, right? So maybe for that we can have a map that will be the character itself and its count, which we can use an integer, right? So that three things we need that will help us to write an algorithms in efficient manner and give the length of the longest length of the substring. So let's see how we're gonna implement this logic in Java. So let's implement the algorithm length of longest substring, and we are going to utilize sliding window technique. So sliding window techniques, we need 2 pointers. So let's define the 2 pointers, and left int right, that also going to be initialized at 0. Then we need to return the longest length, so I will say longest length, that is also going to be initialized at 0. Then we need to keep track of the characters and their length, how many times they appears, right? So for that I'm going to use the collection in hash map, and I will say the characters as a key, and their occurrence will be the value, and I will name it as chars. That will be my new hash map. All right, so these are all the variables we do need to make progress. Now we have to start from the beginning, and we will continue expanding the window until we have a right pointer reach to the end of the length of the string. Okay, so for that I'm going to use the while loop, and the condition I will say right is less than s dot length, which is the length of the string, and every time I'm going to find the char, that will be the element e as char at the index right. Okay, so we get the characters at this, and what we're gonna do, this elements, we're gonna insert this into the map. Remember, the element itself is the key, and we also need to add the number of occurrence, right? So if the element is already present, we have to increment it, and the map provide a get or default method, so that will give the current value or default it to the 0. We're gonna default it to the 0 and add the 1. So how we gonna do that? Get or default. So if the value is there for the element, then we will get the value. If it's not there, then we'll get the 0, and whatever the value we will get, we'll add 1 to that. So that will give us the characters and their count, and we'll increment the count if there is any. Then we also need to make sure that we should not, as long as we find the character which is already in the map, we have to decrement, we have to contract the window from the left side. So how we gonna do, we still gonna use the while loop, and in that we will get the characters, the element which we found at the right index, and see if it's there in the map, and if the count is greater than 1. If the count is greater than 1, that means we have to start contracting our window from the left. So for that, we again get the characters at the left index. Okay, so char at left at, this is how we're gonna get the element at the left index. Okay, then we have to put this left index, right? So if anything is there in the map, we have to decrement the count. So char at left, okay, then we need to get its value, okay, at left index, okay, and then we need to decrement the value by 1. Now we decrement the value in the map, okay, at the same times, because we remove the value from the character map, and we also need to contract the window. So how we gonna contract the window? We just need to increment our left index. Now the left index is pointing to the next element, so the last one is gone. Okay, so this logic here will take care of that. Now we have to, this is what we do, and once we are done, right, whatever we left in the map is the unique characters, right? Now we have to find the length. This is what we need to return. So the longest length is the 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 distance from between the right index and the left index. And how we gonna calculate it? So we're gonna calculate is equal to left, sorry, right minus left plus 1. That's how we gonna calculate. And we also need to understand that we need to keep track of the longest length, right? So that's not, we always have to save this value in the longest length right here, right? And always check if it's max, the new length is max, then only we have to update this. So for that, I'm going to use the mathmax function that will be checking if the longest length from the previous iteration is greater than with the current one, and whichever is greater, we are going to put it back into the longest length, right? And then that will be, we are doing this whole thing until we reach the end of the string, right? And once we end of the string, we simply need to return the here, right, the longest length. That's it. So I hope you understand, right? So for 2 pointers, we need the left and right. That will be my 2 pointers for the sliding window, for the contractions and the expansion. And this is the longest length variables I'm going, so that we can keep track of the longest length, right, while we are iterating through the string. And in this logic, right, we are looking for the characters in the string and getting that element, putting into the map and incrementing its value, right, the number of occurrence in there. And at the same times, we are, if any numbers is greater than 1, for that we have to remove it. We have to remove so that we can, and we also need to contract the window. So the characters as the left, we have to decrement from the map, as well as we have to increment the left index so that the window get contract, right? So that's one thing. And we are not doing the expansion here. So we in the outer while loop we have to expand the window as well. So that will be taking care of it. So let's run it and see how it goes. Okay, so we got the null pointer exception. I think the object is okay. So the null point exception at the value. Oh, okay. So the line number 12, which is this one, and you see this is where we have to put the character. This is the key here, right? So once we update this, I think we should be fine. And as you can see, we are good with the result. Okay, so you can see how the two pointers technique with sliding window is so efficient to solve these kind of problems uh, with linear complexity, right? The time complexity here is on because we have to visit every element at least once, right? Or maybe twice if we are talking about uh, the the inner while loop, right? But it's still constant, so on. And the the space complexity, of course, in the worst scenario, we have to take into the considerations of the map, right? So this is one thing we have. So it's O N, right? So it's still there are some room for improvement, right? We can optimize this, and we can take a look into the optimization of this one into the next session. Thank you for watching.